Right, you are live. Hello and welcome to another Saturday afternoon session from John Chappell Natural Philosophy Society. And today's talk is, are there experiments that show faster than light speed c, which then mean Einstein's relativity is wrong, question mark. Hold on a minute, I forgot to turn the sound off the other computer. Ah. Hold on a minute, I forgot to turn the sound off the other computer. Okay. So back again. Hi. So what I've sort of noticed is often with these sort of talks, when there's a question mark on the end, and that sort of means that you're only going to be a partial answer or an incomplete no answer at all. If I'd title this sort, there are experiments that show faster than light speed c, which then mean Einstein's relativity is wrong, that question mark, then that would mean I had a definite answer. But since this talk's got a question mark, it means I'm not going to fully answer this question. So that's a bit unfortunate. This is my research on this question up to now. So I'm just giving a partial answer. So let's get started. So next slide is slide 2. So the theme has been dealt with a bit before, that there are experiments that we, the distance, think show Einstein's relativity is wrong. But they, the mainstream, think do not disprove relativity, but instead agree with relativity. The issue is thus the problem with how to interpret experiments. First of all, I deal with this issue of faster than light speed c only in the context of relativity physics, and then I'm going to add on the complications of quantum physics. Light speed c is supposed to mean light speed in a vacuum free of the influence of fields and supposedly obeying Einstein's special relativity, but in my view Einstein's special relativity is a bit vague. In the case of faster than light speed c signals, looking at an example, and it comes from this person, Harold Miles. He's mentioned our website of natural philosophers. He was a mathematician, and when he complains about relativity, it's from a mathematician perspective. And in the relevant article dealing with this one, it was articles entitled "Faster Than Light Speed," no, it's faster than light question mark, and this information was provided by Dennis Allen, and it appeared in this issue of Radio Electronics in the year 1983, so it's about 40 years ago now. And so, getting into the article, Harold points out it is quite trivial to do electronic experiments that have electrical signals going faster than light speed c. He says, I've recently been engaged in experimentation with transmission lines and discussion my work with other scientists. If I casually happen to mention, which is sort of fun to do, that I'm interested in electrical impulses that propagate faster than the speed of light, I'm met with a variety of reactions. The most usual is derision, ranging from skepticism or incredulity to outright rejection. On the other hand, there are a few people who say the phenomenon is old hat and well known. So when people are believing Einstein's relativity, they're often in derision about somebody saying they can get electrical signals going faster than light speed. C, you just don't believe it. He continues, the word well might be disputed, but it is true that in the first decade of this century, it was already known that electric waves do propagate in wires at velocities in excess of c, the velocity of light in free space. The fact seems to have been obscured by our acceptance of Einstein's theories of relativity, so that very few people, even senior graduate electrical engineers, are aware of it. We are much more familiar with the idea that the velocity of light has c as its upper limit, and the velocities of both matter and energy are similarly limited, and that no intelligible information can be propagated faster. And he carries on. Since there is some dispute as to whether the speed limit postulate of the relativity theories originated with Poincaré or Einstein, we'll avoid taking sides and simply refer to it as the C hypothesis. It is recognized by relativism, the science of relativity, that the so-called wave velocity of electricity, that is to say the velocity at which the crest of a sinusoidal continuously emitted electrical signal moves through a conductor, can sometimes exceed the velocity of light. That forms an exception to the C hypothesis. So my query on that really is, I don't know whether that exception is really to be considered an exception to the C hypothesis in the context of Einstein's relativity. I think people who believe in relativity would come up with, say, lots of confusing things. So now a diversion onto quantum physics with what he is now said in 2023, as opposed to what the article was saying in 1983. So this, for example, from Big Think, this article says even with quantum entanglement, there's no faster than light communication. And that article says, since the development of quantum mechanics, however, many have sought to leverage the power of quantum entanglement to subvert this rule, that is, about faster than light speed. Many clever schemes have been devised in a variety of attempts to transmit information that cheats relativity and allows faster than light communication. After all, although it's an admirable attempt to work around the rules of our universe, every single scheme has not only failed, but it's been proven that all such schemes are doomed to failure, even with quantum entanglement. Faster than light communication is still an impossibility within our universe. And it carries on to try to explain why. But the basic idea is that faster than light is possible for random information using quantum entanglement, but can't do faster than light for intelligible information. You can't send intelligible information faster than the speed of light. And that's the mainstream sort of point of view on it. But going back to relativity theory without quantum physics context, in arguing in that relativity context as to whether intelligible information can go faster than c, an issue is highlighted more when Sabine video is shown. This is coming up in a minute. So now back to Harold Miles, and he's saying this in his 1983 article. Maxwell's equations seem to describe the properties of electricity best. They predate the theories of relativity by 25 years and were not the only set of equations proposed in the late 19th century to explain the behaviour of electricity, but they were the ones supported by the influential Cambridge School, which was predominant in science at the time. Though Maxwell's equations are very good, where there is a continuous current flow, they are known to be subject to certain errors, particularly in describing phenomena involving moving isolated charges. It's precisely when treating the behaviour of those discrete charges that it is best to modify the equations to agree with relativity as we currently understand it. And so, as a mathematician, Harold is thinking, if don't like the equations being used in physics, then can modify them. But I don't know what physicists think about that. Maybe they think should originally stick to the equations and not modify them. But you've got this point that Maxwell's equations came about before Einstein's relativity, and Einstein's relativity seems to be imposed upon it by the mainstream. And what he goes on to say, when derived directly from Maxwell's unmodified equations, the velocity v of sinusoidal waves in transmission lines is given by the following formula: v equals 1 over the square root of L times C. The values of L and C are not the total inductance and capacitance of the line, but represent its specific inductance and capacitance. That is to say, its inherent inductance and capacitance are determined on a per centimetre basis. So, experiments based on that equation note that this is a capital C, so it's not the light speed C, which is a lowercase c. Experiments based on that, he claims to have fast and light speed C. And so you're just based on that equation, v equals 1 divided by the square root of capital L times capital C. So he then goes on to say, the experiments described below show that there are a number of ways to get the results needed to reach a conclusion. They can be performed by anyone with a little knowledge in electronics and do not require a large cash outlay. All you need are an oscilloscope and a square wave generator. You'll be able to see for yourself that electric pulses do indeed propagate in conductors at velocities fast and c, which is lowercase c, the speed of light, but you're also warned that the results do not establish the validity of the equation v equals the 1 divided by the square root of capital L times capital C, though it's more likely to be true and would be the C hypothesis if it were applied to the speed of propagation of electrical wave trains. And he says, in many cases, I've observed the speed of propagation of square wave trains to be greater than 100 lowercase c. That's 100 times the speed of light c. And that should help to understand the basic idea. You just set up a oscilloscope and you get the oscilloscope to obey the equation v equals 1 divided by the square root of capital L times capital C. So there's other people who've been involved in this, and it's Brillouin and Sommerfeld have analysed the issue that Miles is dealing with, but he finds reason to dismiss what they say. Ideally, I need to go into analysing what Sommerfeld and so forth say, but that would involve a lot more mathematics than I'm dealing with here. And he was writing, and it was also more mathematics than what Harold was dealing with. in the electronic magazine, which the electronic magazine wouldn't want to go that too heavily into mathematics. But basically, Harold Miles is saying that Brillo and Sommerfeld, when they were talking about this sort of issue, they didn't have it quite right. And anyway, from that article, you get the basic idea that the C hypothesis is wrong, and it got published in the electronics magazine. And he received a response in the letters section in the later issue, namely this one. And the first letter, referring to the article Faster Than Light by Harold Miles, it is disputing the interpretation of the experiment. The equation, though, is a simple equation: v equals 1 divided by the square root of capital L times capital C, and the values of capital L and capital C were being chosen so that v would be greater than a lowercase c, the speed of light. So as far as the math was concerned, it was allowing v to be greater than c in the experiments. But this person, Harvey Gluckman from Montauk, is disputing that. So the second letter also condemns Miles as a crank, and condemns the magazine for publishing a crank's article. And that person is firmly locked into believing relativity and does not want to address the issue of why a simple equation, which I keep saying, v equals the 1 divided by square root of capital L times capital C, allows faster than light speed, lowercase c, and does not represent that Miles is a mathematician. So Miles is looking at it as a mathematician. You've got that simple equation for the velocity v, and based on that simple equation, you set up an experiment and you get faster than light speed, lowercase c. So this person, Dr. Thomas Roberts, isn't addressing that issue. He's just criticizing the article being crank. So thus we have the impasse. There are those who believe relativity, in this case the C hypothesis, and it won't address the criticism that distance might have, such as about the maths v equals 1 over square root of uppercase L times uppercase C, and that equation allows the speed of light c to go lowercase c, say nothing about whether information not allowed to go faster than c. That equation for v allows faster than light speed, lowercase c. So now I want to bring in a video clip from Sabine. So Sabine is a theoretical physicist, but she does have some maverick ideas, and she gives her own opinion on certain things. And so, although towing the line on a lot of mainstream ideas, she does deviate a bit from some of the mainstream ideas and gives her own opinion on things. And so, some of the things she says, I don't agree with. And so, I just want to show a clip from her video, and not the whole video. If you want to see the whole video, you need to go to it yourself and decide how much of it you agree with. But the clip I want to show is only about a couple of minutes long. The video starts where she's talking about faster than light speed spaceships and whether aliens could get here. So that part's not really relevant. But she's given 4 reasons why she thinks faster than light is possible. And it's only one of those reasons that I'm really interested in. So I'll show the video clip now. Add to stage, and let's start this up. So how do we get higher?
because I think it's becoming increasingly...
So it's suddenly flipped to the wrong place. So I'll try to put it back.
Accelerate an object. Let's suppose the object has a mass m. This mass corresponds to an energy which is given by the most famous equation ever, E equals mc squared, where E is the energy and c is the speed of light. But now we accelerate this massive object from zero velocity to some other velocity, v. The energy you need for this acceleration is the total energy of the object at the new velocity minus the energy it previously had. In Einstein's theory, the total energy of an object that moves relative to you with velocity v is given by this expression. Now, if you want to know the kinetic energy, you take this and subtract the same expression for zero velocity. So you get this somewhat messy expression, but don't despair, it isn't as bad as it looks. For one thing, when the velocity v is much smaller than the speed of light, then the ratio v over c is much smaller than 1. In this case, the complicated thing with the square root is approximately 1 plus 1/2 v over c squared. The 1 cancels out and the c's cancels out, and you get 1/2 mv squared, which you might remember is just the kinetic energy. But we're more interested in the case where the velocity gets close to the speed of light. So v over c gets close to 1. Then this factor gets close to 0, and the entire energy gets close to 1 over 0, which is infinity. This means if you want to accelerate an object until it reaches the speed of light, you need an infinite amount of energy. Another way to put this is that the only way you can move at the speed of light is when your mass is 0. Even a keto diet isn't going to do that for you. This is where the idea comes from that the speed of light is a limit that you can't cross. But this argument has some issues. The first issue is that it doesn't mean faster than light travel is forbidden in Einstein's theory. Indeed, his theory is entirely compatible with faster than light travel. The problem seems to be instead that you can't accelerate from below the speed of light to above the speed of light. It's more like a barrier than a limit. The second issue is more a peculiarity. It's that on all other occasions, when physicists see some quantity go to infinity, they'll tell you that infinity is unphysical and a sign that the math doesn't properly work. Big Bang, black holes, non-renormalizable effective field theory, whatever. If there's a singularity, they'll say it's a mathematical artifact and not real. They don't say that in this case, and I think they should. The third issue is that we have a counterexample to the claim.
So that is what I wanted to show. She goes on to talk more. Those are the issues I wanted to point out, mainly the second issue. I'll recap it. And so I don't want to go on to the third issue because I start disagreeing too much. It's just on the second issue that I find interesting, that when maths breaks down at infinity, that means go to a different maths. In the case of singularity, when an infinity of maths accepted, that maths breaks down. That's the case of the black hole. When relativity has infinity for energy at speed c, that should be taken to mean the maths breaks down as well. But physicists are being inconsistent as to how they handle infinity. And in that case, so now I want it to mean something else, i.e. to mean light speed barrier, etc., instead of maths breakdown. So that's the point I wanted to make, that they're interpreting infinity in different ways in the context of Einstein's relativity. When it's a black hole, they believe the infinity means that the maths breaks down and you need to provide different maths. But in the case of special relativity, when you have infinity, they're looking upon that infinity as the light speed barrier. So they're not being consistent in how they're dealing with infinity. So Einstein's strict relativity does not address the issue of how relativity is to deal with infinities. where it doesn't properly deal with it. It is usually assumed that in special relativity, when have infinity as speed c increases, that means can't have object go at light speed c, lowercase c. But the proposal is that when infinity turning up, then need to go to a different mathematics. Now, what is talk about relativity is wrong. So what is taught in relativity is the Lorentz-Einstein transformations, sometimes just called the Lorentz transformations, and the Galilean transformations, and that's the mathematics for it. However, in this relevant paper, two myths about special relativity by Rolf, and he points out that the Lorentz transformation do not reduce to the Galilean transformations when the ratio v divided by c is small, which is contrary to what is taught. Students are taught to believe fourth mathematics. I go back to that mathematics there. What students are taught is the at low speeds Lorentz transformations reduced to the Galilean transformations, and that's false. That's what they're taught. They're taught something that's false. They don't reduce. So students are taught to believe in fourth mathematics when they're taught special relativity. Then critics like Roberts, who criticised Miles, believing in relativity, most likely also believes in that false mathematics which they're being taught. So you've got Miles, who's talking from a proper understanding of mathematics, and you've got his critic, who's talking from a misunderstanding of mathematics based upon what he's been taught. So that's what happens is when light speed gets near c, lowercase c, and the mathematics, special relativity becomes infinity, i.e. in the Lorentz transformation and so forth, you need to then switch back to Galilean transformation that gets rid of the infinity problem and still is a valid mathematics allowing speeds greater than light speed c, lowercase c. Those who believe no light speed greater than c are not thinking of things that way and just have their mathematics wrong. Thus, mathematicians like Miles pointing out can have speed greater than c are correct. He's correct in the article pointing that out because they don't have their maths wrong on relevant places in relativity. So I'm going to reach a conclusion for Miles, but on faster than light signals, and then I'm going on to a mathematical excursion. So I'm going to emphasize it again. Mathematicians such as Miles find themselves facing the mainstream that believes in relativity and will dismiss what they say. But the mainstream works from having false beliefs about relativity and mathematics. That mainstream then being unable to see its mistake, dismiss mathematicians as Miles as cranks. And unfortunately, in the dissident movement, there is a section that rebels against mathematizing of physics. So what should be the dissidents pointing at the mainstream have their mathematics wrong, gets diverted often into the dissidents having an anti-mathematics attitude. And that's the conclusion onto that. And I want to go on to a mathematical excursion. I'm trying to explain how mathematics should be done. So when writing equations should really be stating the range of values for that equation as to when that equation is valid. Pure mathematicians do that, and presumably Miles is doing that as well. But physicists seem to be lazy and don't bother. So I'm going to take a mathematical equation as an example. And this is just an arbitrary equation. I can pick any equation. So picking this equation, y equal to open bracket x squared minus 4 close bracket, divided by x, well, divide open bracket, x minus 2, close bracket. Need to say what values of x is the equation valid. It's not good enough just to write down an equation. You've got to say what values is that equation valid. So looking at that equation, if we substitute the value x equals 1, then it turns out you get the value of y equals 3. If you substitute the value of x equals minus 1, then get the value of 1 for y. So the equation is valid for x equals 1 and for x equals minus 1. But if you substitute x equals 2, then the equation becomes open bracket 2 squared minus 4, close bracket, divided by 2 minus 2. And that turns out to be 0 divided by 0. And so 0 divided by 0 is an indeterminate form. So the equation breaks down at x equals 2. And if you go to Wikipedia, it explains what an indeterminate form is. When an equation gives something like 0 divided by 0, then that is indeterminate. You can't really say what that is. It's 0 divided by 0. Some people mistakenly take that to mean it's 0, but it's not. It's how many times does 0 go into 0, which is a nonsense question. So the equation y equals open bracket x squared minus 4, close bracket, divided by open bracket x minus 2, close bracket, should really be written with the condition as valid in real numbers except for x equals 2. So it's not good enough just to write an equation. What you really need to do is write the values for which that equation is valid. And that's the conditions you're putting on the equation. And when we look to Einstein, voice going, glass of water. So when we look to Einstein, he gives equations such as the Lorentz transformations, but he omits to say for what values the equations are valid in his theory. I.e., he's just bad at mathematics, he's lazy in doing mathematics, and he's presented an ambiguous mathematical theory. He hasn't given a proper mathematical equation if he has not provided the conditions for which that equation is supposed to be valid. So this is what one of his math teachers said about Einstein. It came as a tremendous surprise, for in his student days, Einstein had been a lazy dog. He never bothered about doing mathematics at all. So Einstein was lazy at mathematics. And that really means that Einstein was bad at mathematics. He didn't bother to do things properly. So I want to pull up an issue which Stephen Bryan's pointed out. He says he puts in some values into Einstein's mathematics, and he comes up with a value that in those equations that 1 equals 0. And that's from Einstein's equations. Certain values you input into Einstein's equations and you end up with saying that 1 equals 0, which is nonsense. So without saying what the conditions are for those equations, you end up with nonsense. And Einstein didn't provide what are the conditions for those equations. So Einstein omits saying for what values the equations are valid and not presenting conditions on these equations, and then derive mathematical nonsense from his equations. Einstein is just bad at mathematics and should have presented the conditions. Most physicists, unfortunately, follow his example as being bad at mathematics. Ideally, Einstein's relativity should have been discarded as bad mathematics, but physicists being bad at mathematics themselves just went ahead and accepted it. So Einstein says 1 equals 0 because he's bad at mathematics. He didn't write his mathematics down properly. And that's the end for this. Thank you. Opening now to people complaining, I suppose. Hi, hello. Let's see what we got. If we close that down. Oh, I can't find it. No, going the wrong way. Got to enlarge my screen. No. Doing it all wrong. Right. Okay, I can see the comments now. Oh. Should I be going through the comments, or does anybody want to put their hand up in the green room? Harry's putting his hand up. So, hello, Harry.
Okay, Roger. I'm not sure whether you're going to be able to hear me. Last week I had a problem. There's this figure in this electronics magazine article that is referred to. I think I know what the first comment that you presented. I think I know what that meant, but I'm not really sure what was measured because I don't see it. You didn't show us the diagram of how he did the measurement. So how he did the measurement seems to me kind of like I don't really know what he did. So do you have that? Can you show us?
The magazine's probably got that. I'm more interested in the mathematics and the equation that he's using for his experiment is just a simple equation v for velocity v, and without any imposing special relativity on it, then you can adjust the inductance and the capacitance, and you get a speed greater than c for the electrical signal.
I got that, but it doesn't really, I don't really understand. As an electrical engineer, I don't understand what he did. That's my point. I think I understand. I read the article that was sent out that Dennis Allen sent.
Yeah.
And I think I understand where the mistake is, but I'm not really sure. In a way, what happens is when you do these, I don't really know because I don't really know what he measured or how he did the measurement. And that's why I'm saying this confuses me. And do you understand what I'm trying to say here? Without knowing how he did the measurement that results in his claim, I just really don't know what to think of it. I have a suspicion about what to think about it, but I don't really want to say it until I see what he did in his measurement. I didn't see any measurement setups in the paper that was sent by Dennis. The one, the one I'm talking about.
Yeah, Dennis has probably got more information on it.
Well, I didn't see any diagram. Well, there were a couple of diagrams, and that led me to think. I don't really know what to think about this without really having a clear idea as to what he measured. So that's an issue for me. As far as the math is concerned, that's this whole business of Bryant with 0 equals 1, and that. I mean, this sort of thing has been discussed by a lot of different people who pointed these problems out. And no real clear answer has ever been given.
I was trying to point out this is a mathematician's perspective of the issue, and so Miles is a mathematician. And he did those electrical experiments, and he believed that equation for velocity v, and he says, well, the experiment then shows that light speed, the electrical signals are faster than the speed of light, lowercase c. So that's what he did. He just looked at that equation, he believed the equation, and he did it. And that's the experiment. And then if you what the people who believe in relativity do is they want to impose things onto that equation so it doesn't give light speed greater than c.
Well, this is the part I don't really quite understand. the equation L, the square root of 1 over the square root of the LC combination.
Yeah.
Okay, that's well known in engineering.
Yeah.
But the L and the C come from a measurement. Usually you measure the L over C by doing an experiment. Okay, and so then you know what L over C, you know what that equation is when you do an experiment. You know the L's, that you derive the L's and C's from doing the experiment. How he seems to be doing it the opposite way. He seems to be saying the L and C are this, and then does the experiment and says that it gives a result faster than the speed of light. I just don't understand that. I'm sorry, I just don't.
Well, it seems valid to me. As a mathematician, you look at equations.
Well, I got to see the experimental setup. I mean, this experiment's been done numerous times. I mean, this is done on a regular basis by cable TV people. They have a device called a time domain reflectometer, which is basically a fancy oscilloscope, and they send a signal down a transmission line. And when it arrives back, it's displayed on the scope screen, which is basically an oscilloscope, and that tells you where the fault is in the cable. And this is a technology that's been used for years and years and years. Nobody that I know of has ever measured a velocity faster than the speed of light.
Well, no, he says you can. If I go back to that paper, he's saying that he was measuring.
I think there's some kind of a misinterpretation issue going on.
He's
misunderstood.
That's one of the criticisms. One of the papers, one of the letters criticizing, said he's misinterpreting the experiment.
Yeah, that was what the first guy said, and I'm tending to agree with what the first guy said. The second guy didn't really say anything other than "you're wrong because I say so."
Yeah,
that was this guy's a crank. He doesn't know what he's talking about. So therefore he's wrong because I say so, because I know what I'm talking about and he doesn't. That wasn't really an answer. That wasn't really anything. That was just, you're wrong because I say you're wrong. Okay. The first guy at least gave an explanation.
Yeah. Well, I disagree.
Okay. The first guy gave an explanation, which was you made a mistake in your experiment. Okay. I can accept that he made a mistake.
If the setup obeys that equation, then it can give faster than light speed c, lowercase c. If you're saying that it doesn't,
I'm not sure how he did the experiment, so I can't. My point is, I don't really know what he did, so I can't.
You're just choosing values for L in capital C that set up the speed to be greater than c.
But a transmission line doesn't do that. It has its own inherent values of L and C. I mean, you just can't pull values out of the air and say, "Oh, I'm choosing this value," which is, I think, what Milnes did. I think I don't know what he did. So not knowing what he did, I don't know what to think.
Yeah. Okay. But he's looking at it's a mathematician, and that equation allows you to have V greater than the light speed c.
I understand that. But certainly that's a mathematician's way of looking at it. He doesn't have any physical constraints. He says, "Oh, I can make L and C anything I want and get any result I want." But that's not how nature is working. Okay, as an electrical engineer,
as a mathematician, that's how nature works. It works to mathematics.
No, you don't understand what I'm saying. As an engineer, basically, if I want to know what the L and the C is of a transmission line, I have to make a measurement. And the way I measure it is usually I measure the velocity. And when I measure the velocity, it turns out it's less than C. I don't know that anybody's ever measured it as being greater than C. As a mathematician, you can make up any L and C you want and get any result you want. But that's not what nature does.
As a mathematician, doing whatever you like with the equation is what nature does. So it's a disconnect between things again.
Well, I think I understand what his mistake was, but I'm not sure really.
as a mathematician, you're looking at the equation and you're saying for what values is that equation valid? And if you haven't got a condition on it, then you can choose whatever you like.
Well, the bottom line is, as an electrical engineer, okay, when they make these measurements, I mean, you measure, you go out and you make a measurement of a transmission line, and you get the velocity of the transmission line. That tells you that certain values of L and C are not possible for that transmission line, because you can't have a value of L or C that gives you a velocity different from what you measured.
But as a mathematician, you're saying the equation says you can.
I understand that, but as an electrical engineer, that's not how we do things.
Well, you shouldn't be doing it that way. You should be using mathematics. Physics is a mathematical science, and so you need to
look at
things
from
fine. So you need to look at things from a mathematician's point of view, and from a mathematician's point of view, you need to say for what conditions is the equation valid. And for the equation like that, it's not being stated that there are conditions on it. So going by the equation,
it's only valid for a result that gives you a velocity less than c.
As the electrical
that equation doesn't apply for any value
when you look
in C that give you a velocity greater than c.
So I silence you. Sorry, I silence you a minute. So as a mathematician, you're given an equation, and you need to be told what conditions is that equation valid. And if you look to most physics books, most electrical engineers books, they're not telling you that equation is only valid for certain values. It's not making that condition on it. So looking at it as a mathematician, the mathematician is saying, right, you can use any value you like, and therefore V in that equation can be greater than C. So that is another disconnect between science with people who are bad at mathematics and those who are good at mathematics. You need to state the conditions with it. Is that okay? So I go there. Thank you. Okay. I think Dennis has got his hand up now. All right, Dennis, at the stage.
I think Harry, there were two papers. I think Harry only got one of them.
Yeah.
The other one explained the experiment and told all about it. I don't think Harry somehow got that. I sent out both.
Yeah.
But I don't think, maybe he couldn't receive that or something. The thing was about his experiment is it relied on the idea of a Gibbs overshoot. The Gibbs effect is when if you send out square waves, and try to Fourier transform them, you find out that there's a problem because the convergence is not absolute. It's just regular convergence. And so there's something called a Gibbs overshoot.
Yeah.
And let me see if I can show it.
Yeah, unfortunately, I wasn't able to deal with that. I'm still looking at Sommerfeld and with Visualent.
Well, let me just show it. Should be able to find it here. I have a copy of the longer article. See, this shows various. I don't know if I want to do that one. Oh, I guess I better, yeah. All right, this has 10 diagrams depending on how far down the line you are. And the first and second, especially the second, show the Gibbs overshoot, which mathematically has to appear. And this Gibbs overshoot, even though the signal from starting out as a square wave, as it goes down the line, it gets deformed. The Gibbs overshoot could still be observed way down the line. And so it gives you a reliable way to measure velocity. Now, Harry seems to say that you just send the signal down, you wait for it to come back. That's a different way of measuring the velocity of the, and I don't, since I'm not an electrical engineer, I don't really know how these two methods are related. Maybe Harry would, because he is an electrical engineer. But the point is that there's this Gibbs overshoot, which, because of its characteristics, is preserved way down the line, even though the square wave turns into sort of a different type of wave that sort of resembles waves on an ocean or something, the surface waves on the ocean.
Yeah. Okay.
So Harry ought to read this other paper. If he, I could even send him in through the mail if you give me his address. If he can't receive it,
he's in the in our email group. You've been sending out to our group, haven't you? Me, Ian, Karen. I think Harry was in on that. You're sending out CC to us all.
well, he seems to have only received the faster than light one that you showed on the screen with a lightning bolt that appeared in that radio magazine.
Yeah.
That's not, he's right in saying that Milnes in that article does not explain what he's doing in the experiment. And so, and I sent out both articles at some point, which I think he may have either skipped or maybe he couldn't receive it on his, it's a long file. Maybe he, his operating system, his browser couldn't handle it. I don't know, but he ought to look at that because Milnes is very carefully explains just what he's doing.
Yeah. Okay, thank you. Ian's got his hand up now.
Okay.
Well then, thank you. Cheers.
You're welcome.
Thank you. I just hi.
I have to unmute myself. Yes. Hello, everybody.
Hi, Ian. Thank you.
Now, if I may, Roger, I had a few points to make, and I think one of them, at least, will deal with some of the matters that were discussed just now.
Yeah.
Raised by Harry and Dennis. Well, so number one would be electrical phenomena. The speed of transmission of an electrical signal through a hardwired system. Now, my understanding, because I looked at this Milnes business, some time ago when I was preparing the papers on this, and I'm not sure if it's described in the current papers which were sent out by Denny, but my understanding is that he actually repeated experiments which were done in the middle of the 19th century by a Frenchman by the name of Pouillet, Pouillet, in 1853. Now, I thought, and I haven't looked at the papers very recently, so forgive me, but I thought that he'd used these frames whereby he had wound these wire frames many times around very high-rise buildings and measured the speed of transmission. Now, whether he'd used the Gibbs overshoot for that or a reflection system or a more basic system, I don't know. But my understanding is that he did experiments, Milnes did, and he found that the speed exceeded considerably that of light. Now, not just multiples, but maybe, I seem to remember, or perhaps I'm talking about the original French experiment in 1853. It was like something like between 20 and 100 times the speed of light. Now, I also point out myself that I'm just getting the text now. There are minimal delays in a hardwired transmission relative to what would be expected if transmission took place at the speed of light. So, in other words, we've all experienced maybe a satellite broadcast where there's a satellite broadcast, but there's also a hardwired transmission, and there's a bit of a delay between the two. And they say, oh, well, the hardwire is a bit faster because it has to go up and down to the satellite. So sorry, there's a delay in the line. It's a second or so. But it's actually, the delay is much, much more than would be calculated by the mere transmission to the satellite at the speed of light. Okay, so I just said, yeah. Okay. Now, so that's the first point. Maybe I want to make. There's about 5 points, if you permit me. Now, so the next one, that's electrical in hardwired systems, and I think the experimental evidence is there. Now, the other thing is another phenomenon altogether, where we talk about the speed of interaction of gravity as distinct from gravity waves, which are perhaps transverse in nature, and they might transmit at the speed of light. But this gravity interaction is more of a potential type thing. Now, Newton took it to be instantaneous, which I think is a better view than taking it at the speed of light. But I as a mathematician, also resile from anything instantaneous. So I think, this man who's deceased now, Tom van Flandern, did a lot of work on this, and he said it might be, 10 to the power of 10 times the speed of light. And Laplace actually had done the work in the 18th century as well, the mathematician, based on the stability of the planetary orbits. And he said, well, it must be greater than, I think, 10 to the power of 8 times the speed of light. So that's another thing. Now, relativity, say, gravitational interaction takes place at the speed of light. Now, one or two other things. So the other one is this business of a refractive index being less than unity. And if it were less than unity, well, then the speed of transmission in that medium would exceed the speed of light in vacuum. So again, I'm just getting my text out, so I don't have to remember what I said. But I said, in the case of the ionosphere, relative permeability. See, remember that the V equals 1 over square root of LC, but in the ether, if you like, if I may use the word, V equals 1 over the square root of mu naught epsilon naught. The permittivity and permeability.
You froze then.
The capacitance and
sorry,
inductance per
you
unit.
froze. Sorry.
Did you not get me there?
Froze then.
So can you hear me now? Just as the V equals 1 over the square root of LC, where those are, I think you pointed this out, the inductance and capacitance per unit length. Well, if you take that in the ether, if I may use the term, those figures are epsilon naught and mu naught in free space, the capacitance per unit length of the ether and the inductance per unit length. So permittivity and permeability, C naught equals 1 over the square root of epsilon naught mu naught. I'm using C naught there just to indicate that it's in a vacuum or in the ether without any other fields there. So in the case of the ionosphere above the Earth's atmosphere, the relative permeability does not effectively change. It's roughly the same as we're getting in the so-called vacuum. But relative permittivity, which is the dielectric constant, is actually less than 1, as the electric polarization is 180 degrees out of phase with the electric field, so that the wave speed exceeds that in empty space. This exceedance depends on frequency. There's typically some 8% increase at single figure megahertz frequencies. And this indeed is what bends waves entering the ionosphere back to Earth and permitted Marconi, against establishment predictions in 1901, successfully to transmit non-line of sight radio signals between Cornwall and Newfoundland. So I'm basically saying that a sky wave bounces back by the ionosphere owing to effectively a total internal reflection, because it's coming from this medium at a critical angle. And this, I know we had some discussion about this, which perhaps wasn't completed, but it's usually when you put this to the mainstream people, they explain it. Now, we're not necessarily talking about wave speed and group speed, because the product of those two, according to the mainstream, would be equal to c naught squared. And if one is greater than unity, the c naught, the other must be less than. But we're talking about, they're admitting that this radio wave, if you actually measured the time of transmission of the radio wave in some means or other, say between Cornwall and Newfoundland, for example, you would find that it actually gets there quicker than the speed of light in free space. But they say that this is the speed of the wave, but the speed of the transmission of information, it must be encoded some way, say in a modulated, super heterodyne system with say two waves coming in and one getting beats out of that. They're saying that cannot be superluminal, but they don't give any explanation for that. They just, as a question of dogma, say information cannot be transmitted.
Yeah. So what they really should be saying is what conditions the equation is valid, and that's what they're missing out.
Yeah, they're basing it on authority, I would say, of relativity. Okay, so that's the next point.
Without putting the conditions on the equation, without saying what the conditions of the equation are, then they're just doing bad mathematics. You just look at the mathematics and you say, well, there's no conditions imposed upon it.
Yeah. I see the point you were making, although if I may just make a very brief point here, I think one could work out equations for other values, such as the one you gave, which blows up when x equals 2, I think it was.
Yeah.
One could get the limit of that equation as x approaches 2. And one could use things like L'Hopital's rule, where one gets the differential instead of getting 0 over 0 in indeterminate form. We could get the thing, and I think in that case the equation would actually be valid. Since you have an x squared in the top and an x in the bottom, I think you would find that it goes to 0 or whatever.
Yeah.
Anyway,
so that's part of the conditions. It's sort of like the equation I gave as an example. If you go by what's given as the equation, then it should break down at x equals 2. But if you want to adjust the equation, then it suddenly becomes valid at x equals 2. And that's if you manipulate it around with what you say, L'Hopital's rule and that, so forth. But they're not, with the people, the mathematicians are not, no, not the mathematicians, the physicists are just being lazy with the way they treat your mathematics. They're not saying what the conditions are for the equations they're giving us.
And I think I've got 2 more points, but maybe I'll bring this one in now since we're talking about those equations. I didn't quite understand, Roger, how you differ from the usual statement that the Lorentz transformations reduce to the Galilean transformations as V goes to 0, because I would maintain that they do.
Well, I refer to the paper. You have to see the paper. But according
what
to
paper is that? Your
paper I refer to. Can I call it up?
Yeah, because I didn't see that.
There we go. Back to it.
Is this the Stephen Bryant business?
Stephen Bryant pointed out that you can put values into Einstein's mathematics.
Well, I think I've looked at that paper, and I see the point that you could put various values in it. It follows from what you said earlier. However, I don't agree with the conclusion that...
which one? Sorry.
I don't agree with the conclusion. I mean, again, it's a simple exercise, just looking at limits, the limit of those transformation equations. Anyway, we can come back to that. It was just by the by. My last point...
Sorry,
you might want to come back and explain that, because I don't agree with you at the moment. But... the last point is that even the mainstream would say, most of them would say that what perhaps you were intimating at, that the Lorentz transformations and so on, they only blow up when you take a mass which has a finite value at subluminal speeds and then try to accelerate it past the speed of light. But if you have, so they're willing to postulate a particle called a tachyon, which actually does travel faster than light. In fact, it cannot travel less than the speed of light.
Yes,
because
that's right.
It would have an imaginary mass at that point.
So, that is the mathematics. What the way they're interpreting the mathematics, you've got this barrier at the light speed. You can't accelerate to light speed c, but beyond light speed c, there are particles going at that speed. But I don't think they've done
I think they normally say if there's a barrier, you say if you're on one side of the barrier, you can't traverse it to the other side.
That's
but
right.
I think many of them would tend to say we have never got any evidence for these tachyons. It's a theoretical possibility. They're willing to entertain it.
But that's them doing the mathematics wrong again. I mean, based on what they believe about mathematics, the Lorentz transformations reduce the Galilean transformations at low speeds, and that's false.
Well, I'd love you to convince me of that, because I disagree with that. I think they do.
I could do a talk on that.
They do reduce the Galilean.
I could do a talk on that. It's this paper by Ralph, which has really impressed me, which can you see on the screen now? And he points out the Lorentz transformations do not reduce to the Galilean transformations at low speed, and that's really impressed me. And so what's being taught is the Lorentz transformations reduce the Galilean transformations at low speed, and that's false. That's mathematically false. And
I'm basing a lot of my work on that. I consider that true. So I'd really like you to convince me.
That is what is taught. They are teaching you the Lorentz transformations reduce the Galilean transformations at low speed, and that's invalid.
Well, I was taught that, but I've also validated it myself, because everything I was taught in this area I've checked, and I found maybe 80% of it was incorrect.
These are the Lorentz transformations, and they don't reduce.
Well, there you are. Just let V over C tend to 0, and you'll find they must reduce. It's simple mathematics.
V over what? C?
Well, V over C. V over C is the ratio of the speed, of the particle to that of light. Now, if V over C tends to 0, well, then the gamma factor tends to unity, and therefore you simply get the gamma transformations.
But the time thing doesn't. Time one doesn't reduce to.
Well, it does, because the gamma is 1, and V over C, it goes to 0. So that dependence on X disappears.
If you look at it, is there an arrow on my thing? Do I have to do a pointer?
No, I don't think so.
I know.
It's not coming through anyway.
I don't know. Is there an arrow?
I can see what you're referring to. The dependence upon
T prime equals gamma open bracket T minus V X divided by C squared close bracket. That doesn't reduce to the Galilean T prime equals T. That's false.
Well, it does. It does manifestly, because gamma.
Because the
okay, listen to me just a second. Gamma approaches 1, and V approaches 0. So T dash equals T.
No, as V approaches 0, you can make X tend to infinity.
Well, why should you? You can make it.
You can do that, and so in which case it doesn't reduce.
Well, only if you want to prove something that you're stating.
This is mathematical proof I'm talking about, and so basically,
X is an independent variable, and it can be any value it like. You could take it outside the bracket there.
No, it doesn't reduce. And that's the point.
You don't need to make it infinite.
That's the point that Ralph is.
I think we should probably discuss this offline, because I don't think we're going to get anywhere. But I'm sorry, Roger. I think you're 100% wrong here. You haven't convinced me, and I'd like to hear what other people think. There's no point in having a one-to-one argument. We could go on forever. Sorry. I'd like to hear what other people think about this.
This is what Ralph is pointing out, that doesn't happen. The Lorentz transformations do not reduce to Galilean.
Well, you've accepted, have you, that the X transformation does reduce? You're saying it's only the T transformation.
Well, you can, I think so, isn't it?
Does he say that the X transformation?
Yeah, it's gamma tends to 1. Yeah, it should be.
Okay, well, at least we're halfway there.
But no, that term Vx divided by C squared doesn't reduce. You can as v.
Well, I don't, I don't like this bringing in an x just to prove a particular point. But we could say that the Solari transformations. Remember, we've had a talk on that. Would actually, because that doesn't have that. There's no dependence.
The Sorelli transformations is another argument. I'm talking about the Lorentz transformations. I'm talking about what's taught. What is taught is wrong. What they teach.
Well, I don't agree. We'll have to agree to disagree there. I think this paper is wrong.
But the math doesn't. When you do the math, it doesn't. It doesn't.
No, I think that's wrong. They do. The mainstream is right there. I'm not afraid to say that the mainstream is right.
If you make v equals 0, then it reduces. And if you're doing that, that's false. You shouldn't be doing that.
Well, but you've agreed that the x transformation reduces to the Galilean when v equals 0. So why are you doing it in one case and not the other?
Well, as you reduce, as you make v smaller, you can make x larger.
Why should you make x larger?
Because that's what you do in math.
It can be any value.
Yeah, v can be any value, x can be any value, and so if you're going to reduce,
x could be 0.
Yeah, yeah. So you got 0 times 0, but in general, you've got no reduction because of that term v x divided by c squared. And I've gone back to Einstein's relativity because he wrote it in German, and it's been mistranslated into English, and it's a misinterpretation to think the Lorentz transformations reduced to Galilean transformations. That's not the type of thing.
I think at the very least, that's an incorrect statement. I mean, or it's a misleading statement. You could say, because there's a spatial dependence for the transformation of time. If you might say this, I'm trying to rephrase it, if I may. Can you hear me?
Yeah. What are you saying?
You've made a very bold statement that the Lorentz transformations don't reduce the Galilean transformation.
Yeah,
when v approaches 0. I say they do.
Well,
now, what you've tried to explain, I think, should be put in some other way. You should say, well, the time transformation has some problem because there's a spatial dependence, and that can go to infinity. If you said something like that, I could.
You could say that the time transformation has some problems, but that's still not what it's taught. I'm referring to what is taught. What is taught is false. They don't tell you there's a problem with the time transformation.
They give you the equations. They derive those equations. And they say, well, all other things being equal, as v goes to 0.
Hold on a minute. Can you hold on? When you say all other things being equal, they don't really say that as well. That's another add-on. If you're looking at those equations straight as they are, what they're telling you is that those transformations reduce the Lorentz transformations, reduce the Galilean transformations. They don't add on extra things like saying all other things being equal. They're not saying that.
Well, I really think you're nitpicking because they've given you the equations. They've given you the equations.
Sorry, yes.
Okay, let me finish. Just a second.
Okay.
You're interrupting me as well. They give you those equations. It's simple algebra. And it's up to the student, say in first year physics, to decide whether they reduce or not. So they're not sort of teaching you something that is arcane, that isn't in the equations. They just give you the equations.
Well, unfortunately, when you do the education system, they teach you things and they tell you to go away and find out, test it for yourself. And if you come back and disagree with the teacher too much, you're going to fail the exam. And so basically they're teaching physics students to do bad mathematics. And in doing bad mathematics, you then pass the exam. And those equations don't reduce.
Well, I agree with the first part of your statement. In fact, I would go further. I would say that they teach you dogma. They teach you not to think for yourself.
Yeah, that's it.
But what you're saying here is misleading. I'm sorry.
No.
I think we should stop the conversation now because we can go on forever.
We can stop it.
And it might be interesting to see what other people think.
We can stop it.
We're in disagreement about that. I say they do reduce.
Well, you disagree.
Anyway, thanks for your pairing with my point.
But basically, this is the paper I'm showing now that shows you where this is dealt with. And I've checked with what Einstein says in German, and basically what Einstein's saying in German gets mistranslated into English. And so this interpretation that Lorentz transformations reduce the Galilean transformations at low speed, that's false. That's not the type of thing that Einstein's really saying in his 1905 special relativity paper. So basically, false mathematics is being dealt with. Students are being taught physics that is false. And it goes back to this idea, if I move on now, when you've got equations, you've got to say, for what conditions is that equation valid? And I gave the example of this equation, y equals, open brackets, x squared minus 4, close bracket, divided by, open bracket, x minus 2, close bracket. It's not good enough to just give an equation. You've got to say, for what values is that equation valid? And when you look to Einstein for that information, Einstein does not tell you that. And so when he hasn't told you those conditions for the mathematics, he hasn't dealt with the mathematics properly, and he's been bad at the mathematics. And it's summed up by Einstein was a lazy dog. When it came to doing mathematics, he was lazy at doing mathematics, and he wasn't prepared to nitpick, if you want to call it, to actually give you the precise mathematical details of when an equation is valid. He didn't bother to do things properly in mathematics. And so what he presented us with is an ambiguous theory. And so when you go to equations like this, when you go to equations like this, he's not telling you when that is supposed to be valid or not. What values are those equations valid? And this is I've pulled out from various texts, and they don't tell you. They don't tell you the mathematical conditions for these equations. They just give you the equations without saying what are the mathematical conditions for them. And so, not telling you that, they then go to you as a student. You go to physics courses, and they just teach you false mathematics. They're just going to make things up which are mathematically false. So if you go by Ian Curran, if you want to believe that Lorentz transformations reduces to the Galilean transformations, then you're just violating mathematics. You're not doing mathematics properly. And that's the way that the physics establishment seem to want to do physics. If we go back to Miles is doing that equation, V is equal to 1 divided by the square root of capital L times capital C. And that's the mathematics you're given. And, well, what conditions are there for that equation to be valid? And that's not being told to you. So as a mathematician, you're saying, well, that can be valid for any values. Unless they tell you it's only valid for certain values, then it's valid for all values. And so mathematically, what the physics community are doing and what the engineering community are doing bad mathematics. They're not presenting the mathematics properly. They should be presenting the equations and the conditions for which those equations are valid. And without doing that, it's all just a mess. It's all summed up by following how Einstein deals with mathematics. There he goes. If you look at Einstein's mathematics, you can just end up with V equals 0. And that was demonstrated by Steve Bryant. And that's basically it. Based on properly handling mathematics, a person like Miles, who's a mathematician, ends up with the conclusion that you can have faster than light speed signals, electrical signals. And people who want to believe in mathematics, and no, people who want to believe in relativity, just want to mess up the mathematics. Right, I think no more hands going to turn up, so I can. No more hands. Right, no more hands in the green room, so I can go through the comments. Right. Oh well. How is let's go this one. How is such instant propagation possible? Well, I'm not dealing with that. I'm dealing with the mathematics. So show, yeah, sound can go faster than light. Yeah, that's another problem with the mathematics. If you've got equations for sound in in, in certain materials, well, for what conditions are those equations valid? Going down through the comments, see what's relevant. Oh, well. So is this idea sort of mainstream or outside of it? Well, I've tried to present what the mainstream's point of view is on things, and from the mainstream point of view on things, they don't really believe in faster than light in signals in the context of relativity, but then they start messing things up by bringing in quantum physics consideration. So yeah, faster than light for sure, but always will be light, just like look to Horton Arp. Yeah, I think from what I've understand from Horton Arp, he was pointing out that relativity is wrong if you are believing in signals can't be faster than light speed c. And so looking at the astronomy from a correct understanding of mathematics, then what Arp is pointing out is their cosmology is wrong as well. So in my view, objects are massive convergences of longitudinal waves within the ether. Well, I'm actually dealing what the mainstream is saying, and I'm disputing that they got the mathematics wrong, so I'm not really dealing with that. Just going through the comments. Why couldn't you just state your views instead of always referring to other texts? Of the way, if it's referring to me, the way I do things, I read texts and I start disagreeing with them, and so that's the way I do things. I read a text and say why I disagree with it, or alternatively, I say why I agree with it. Einstein obsession syndrome. Well, I think the mainstream's got that. They're obsessed with the Einstein, and Einstein makes a mess of his mathematics, and the mainstream wants to do the same. isn't all physical mathematics based upon what the reality shows as the truth, that each mathematical system is arrived at after the observation and understanding possibility is true? So what you're doing with physics really is applying mathematics to observations. So if you've got an equation, you have to say, under what conditions does that equation fit reality? And following Einstein's example of how he deals with mathematics, he's not going to do that. So the physicists have messed up their mathematics. So I don't think there's anything else relevant in the comments about the talk. So seem to be talking about other things like forces and so forth. And so is there any more people in the green room want to hold their hand up? That's like scared Harry off. All right. Nobody else? Anybody want to put their hand up? Excellent. So we can make this a short talk then. Thank you. So if necessary, let's see. If necessary, I can do a talk going through the mathematics of this paper. He points out that what is taught about relativity is false, and he's pointing out two myths there about relativity, and that there are other people that are pointing out that what is taught for relativity is false. So basically, there's a lot of mythology with relativity now. There's a lot of false statements being made about relativity, and these statements about relativity often are mathematically false. So students are taught to believe in false mathematics. And as I pointed out in some of my other talks, what the physicists do is they move goalposts all the time. And so if they suddenly realize they're doing something wrong, they will move the goalpost and say something else instead and pretend that's what was always meant. And so if Rolf gets accepted by what he says here about Lorentz and Galilean transformations, then, sorry, voice is going again, then the mainstream will just move their goalposts and pretend that's what they meant all the time, that the Lorentz transformations don't reduce to the Galilean transformations at low speed. So at the moment, they are teaching to physics students things that are false. So I think that covers it all. Thank you. And I can close down now. Dennis is back now. You want to say anything, Dennis? No, I don't think anybody's putting their hand up. I think I've scared Harry off. Oh, yes, at the stage.
I think the better way to state that the Lorentz transformation doesn't always reduce to the Galilean transformation is my comment here. In the Lorentz transform, you can let x tend to infinity faster or slower than letting v tend to 0. And then you get different answers than the Galilean transform when you do the same thing to it.
Yep, that's it. That is, I think, what's being pointed out. So really, that's what should be taught to physics students, but that's not what's being taught. They're not going into that sort of explanation. Instead, they're just telling you the Lorentz transformations reduced to Galilean transformations at low speed without going into proper explanation. They're not providing it properly.
Yes, but a lot of students, this is taught in elementary physics courses. They don't understand the mathematics that is involved in letting b tend to 0 and x tending to infinity at different rates of speed.
Yeah.
It's
So
sort of, it's
the physics, most cases, the students are trusting the teacher, and if the teacher's got it wrong, then they're not going to dare point out to the teacher that the teacher's got it wrong.
no, because they're very sensitive. The teachers tend to be very sensitive, and they, they'll grade you down if you
That's
make
right.
trouble.
I used to get browbeaten because I always used to complain with what was being taught was wrong. I'm sort of that horrible person. But most students would just sit there and absorb what the teacher's telling them and believe it, and then put it in the exam. So what one way of commonly explained teaching is to say that teaching is the transfer of the lecturer's notes into the student's notes without it going through the mind of the lecturer or the student. They're not really thinking about it. They're just transferring notes without thinking about what's being said. So
Well, oftentimes the lecturer is aware that there are problems,
so
but he knows that if he brings these problems out into the open, he'll be canceled in the academic cancel culture.
Yeah,
he
that's
won't.
right.
I remember when I was at the University of Michigan, someone pointed out the teacher I had pointed out some things that he shouldn't have, and then a senior professor appeared in the next class where he was teaching, and started telling everyone that what he said was wrong and so on. He just basically completely undermined the teacher.
Yeah.
And then the guy quit, or either that or was fired, or maybe he quit because he was going to be fired. But
the teacher quit. Is the teacher quit?
Yeah, because
when I'm a student,
they came right into his classroom and shouted him down.
Yeah, when I'm a student, I'm really horrible. But in the case of, say, studying something like relativity, you need a really big background in understanding mathematics before you go to get taught the physics to understand that what they're teaching is nonsense.
Well,
and if you're a student and you're set,
the problem you're facing is this.
Yeah.
Maybe it's nonsense and a completely correct, relatively being completely correct. But if it, if you learn it and then you can apply it and get good results, then you're basically arguing against success, and which is gives you a hard road to go.
But I'm pointing out they are being in not so much in this video, but I'm pointing out that people who believe in relativity are inconsistent, and in this one I'm pointing out they are being inconsistent with how they use infinity. They will use infinity one way when it comes out in their equations, and then in another set of equations they will use it that means something else. They're just being inconsistent with how they're doing mathematics.
Yeah, but
okay.
The fact that applied physicists can use what's being taught today and come up with amazingly interesting and useful things, means that if you're arguing as a perfectionist rather than as a engineer would. You're saying, well, in a certain situation here, this doesn't work, and so strictly speaking, we have to say that it's wrong. But if you use it, as we talked before the meeting, and there's this fellow Vivian Robinson who has this paper, Physics physics explanation of Einstein's gravity. He is an Australian industrial engineer and physicist who has a firm that makes electron microscopes. And his microscopes are good sellers because they work good. Now, the fact that he's got it wrong about Einstein's general relativity in general doesn't mean that in particular he can't produce better electron microscopes than anybody else, and then so be successful commercially. And then another good example is William Happer, professor emeritus of physics at Princeton. He and his team, when he was a professor, instead of a professor emeritus, developed what's called the spin pump laser, which they use magnetic fields and electric fields to spin up electrons. All electrons have spin, but they spin them higher and higher, and then they let them wind down and irradiate laser light, it turns out. So, and they used Einstein's relativity in the process and theories that are adjacent to it. And it worked, and so he was very successful as a professor of physics at what did I say, Princeton. And so I have sent him some stuff, and he isn't interested because he feels that he knows what he knows because his spin pump laser works, And so how am I to argue against that when I'm not at all talented mechanically or electrically as far as equipment is concerned.
Yeah.
I've never used an oscilloscope for anything. But so that's the sort of thing you're faced with here. You find yourself considered as the best of a terrible perfectionist and as worst a crackpot in a crank. And no, they're not interested in your theories because the theories, they use the old theories like SRT and they get good results provided they're careful how they use it. Now, SRT, as Nick Percival points out in many of his lectures, it works pretty well in an Earth-centered frame, the ECI frame. And that's, of course, what Happer, for example, his spin pump lasers were in the ECI frame.
Yeah.
And so to tell him that around Venus or Mars or something, that you get the wrong result, it doesn't really resonate with him, especially after all its hard work, which was successful.
Thank you. When people talk about relativity, the people who believe it, they believe in general relativity and special relativity, and they say things like when gravity is too strong, you need to move from special relativity to general relativity. And once again, you got the equations which are shown here, the Lorentz transformations. They're not showing, well, how do those equations change? What value is the gravity supposed to be for those equations to stop being valid? They're missing out the conditions, once again, of when the equations should be valid. They're just missing it all out. They're not properly explaining the mathematics.
Yeah. For example, Terry Demise is a Belgian alternative physicist who really likes Einstein's GRT. And when I pointed out to him that Van Flandern, which you mentioned, noticed that if GRT were right, gravity would propagate with velocity c, and then the outer planets wouldn't have stable orbits. I convinced him of this, and his reply was, okay, I agree with the outer planet thing, But otherwise, Einstein's GRT gives really good results, and then he listed some application.
Yeah.
And I wasn't in a position to say that wasn't true. It probably is true, in fact.
Well,
But,
what you should be asking, what are the conditions for the equations when it stops working, because they're not given it.
yes.
They're not given the values. What values are these equations for? They're missing out. They're missing it
Yes.
out completely.
But if they did so, they'd be canceled by the academic cancel culture.
I don't know if they would be cancelled. They just find themselves in difficulties
Well,
trying to
no,
explain it.
Terry Demise does not publish. Well, the thing is that it's not good enough to write it in a textbook that this usually works or almost always works.
Mm-hmm.
You have to say it always works, or they'll buy someone else's textbook.
Yeah. You've got to say what conditions the equations work for, and they're missing that out. They're just, what we show on the screen, the Lorentz transformations, they're not saying what values is that equation valid for.
Yeah.
Just miss it out.
Engineers, don't want to hear this is almost always right.
Yeah.
Because if they build a bridge and it falls down,
yeah,
they're toast.
Well, engineers usually build something and see whether it falls down, don't they? And then if it falls down, they know not to build that thing again.
Well, but as a personal matter,
got examples.
A personal engineer that built a bridge that fell down,
yeah,
his career would be in the tank.
Well, there's examples, isn't it? Like the one called Galloping Gherkin.
Oh yeah.
You got examples of things being built that fall down.
Sometimes it happens, but
yeah.
The guy that designed the Galloping bridge, I think it's probably safe to say that his career went into eclipse at that point.
Yeah.
Which is, good because you want to keep people from doing things like that if you possibly can. But so it's a terribly difficult thing to change a lot of these paradigms because they've resulted in so much improvement in technology, even though they're not quite right.
They can just bodge at the maths. When they do the math, they just bodge it, and then they say they're not. And really, they should be properly explaining the mathematics, and just letting them get away with bodging. It means they can do that forever, and I call that just moving the goalposts.
Yes, that's right.
So they've got away with it too long. Einstein was a lazy dog. He didn't properly explain his mathematics, and so they just accepted that, and then they can just bodge the mathematics, what he's presented, in whatever way they like.
Yeah. There's a lot, but the engineers are much more careful. They have to.
When they build something, or when they've got to try to make it work, and what they're concentrating on is making it work rather than concentrating on the mathematics.
Well, there's a relationship there.
They're not then normally going back and bothering about what was the mathematics I was using. When they built something and it works, then they're happy with that.
Yeah.
They're not really bothered about what was the equation and what was the conditions for the equation. They're not bothered about it so much. They're just trying to make things work. They're not considering the theoretical side of it.
Well, the engineers can be canceled too by the physicists. Physicists outrank engineers. Physicists can say, this engineer is saying something that's against science, and so he ought to be fired, or whatever. Of course, this is of limited value. For example, the Boeing engineers produced inertial propulsion in there, and they use it in their smaller lower orbit satellites in order to keep them from falling down and burning up.
Yeah.
So that Boeing is not likely to be convinced that their engineers wrong just because they don't believe in Newton's third law.
Yeah.
But that's Boeing is a big firm.
Yeah.
A few, and even at Boeing, there was a 2015 talk by Mike Gamble, who was a supervisor at the time for Boeing, about how Boeing's inertial propulsion technique, and it was approved by Boeing for the talk. There's an approval number on the first slide. But afterwards, when they got flack from the physicists, they no longer talk too much about that. They pull like a turtle pulling its head into its shell. They don't want any bad publicity whatsoever. They're out to make money, not to advance science.
Okay. I've just seen a comment here. I've got one here. So I should put the comment up. So I'll put this comment up. Yeah, so this person thinks that Einstein was quite accomplished mathematically, but when you read about it, Einstein was helped in his mathematics by various people, like his best friend and so forth. And what is thought that in 1905, his first wife was helping with the mathematics. So basically, he was going through life with people helping him with the mathematics. So when it comes to Einstein as a lazy dog, well, other people were helping him. On the issue, Minkowski, he did try to tidy up the maths a bit for relativity from what Einstein had presented. So the maths was basically messed up by Einstein. Okay. Okay, I think that's it. I've got to go now. See you next time. Okay, thank you, Dennis.
You're welcome.
I'll put you down now. I'll move you back. So, sorry, thank you. You move. Right. So basically, that's it. Einstein's a lazy dog. The mathematics he presented was a mess, and the physics community wants to carry on in that sort of way. And if I can, I will pick up on the myths of relativity. This person, Ralph, deals with two myths, and other people have dealt with the myths of relativity as well. Basically, what is being taught about relativity, both mathematically and descriptively, is false. So you've got this split between people who want to do the maths properly in Einstein's relativity and the mainstream, which are tending to mess everything up. And they're teaching it to the next generation of students all the time to have a false belief in mathematics, to believe mathematics is false. And I think in the comments there by John Chappell, you're explaining to Ian a bit about why what the mainstream says about those equations is false. When the mainstream says they reduce at low speeds, that is false. You need to go into a lot more explanation as to how those equations are connected. What is taught to relativity is wrong. And so that makes a really big problem if people who believe in relativity have got everything wrong. So thank you. I shall end this talk now. Thank you. See you next time, hopefully. Bye. End stream. Ciao.